record. What we're going to do today is do the practice test. So I will share my computer screen. Not that, but this. If you are taking the AB exam on Tuesday, then you want to be doing this. If you have an AB notebook because you have been in AB all year, then this is the only one you have. If you're taking BC, then you have both, and yours has a little BC after it. Lauren, you've already done the BC one, so I would try doing the parts of the AB one that you haven't done yet. Okay? You were supposed to come to class with pages all set, with your initials and a fake APID numbers so that you're all ready to take this and do it just like you will be on Tuesday. And so I am just going to start my timer. I will give you a 5-minute warning at the end. And then we'll talk about how you're going to upload it, and then we'll go over it. So go. All right, so I just want you all to remember, for one thing, that you don't have to answer all parts of both questions to get a 5, okay? The website says it's designed so that you're not going to be able to do that. Okay, so my advice to you would also be to kind of skip around and make sure that you're answering the things that you know how to do. So I'm going to share my screen and let's talk about this. Okay, so we're going to go over the AB part first because that is common on both. Well, we're going to go over the AB part. If those of you who are in BC want to stay an extra couple minutes at the end, we can go over that. Okay, so particle moving along the x-axis, differentiable function. Remember that differentiability implies continuity. VP of t is measured in meters per hour, t is measured in hours. So justify why there must be at least one time at which v prime of t is equal to 0. Why do you think that's going to be?
I said, is my mic on?
Mm-hmm.
Okay. So do you want me just to read my whole answer?
Go for it. Go.
So I said, according to the mean value theorem, due to the continuity and differentiability of the interval, the value of the mean of the instantaneous rate of change between the intervals c must exist. And in this case, c equals 0, so therefore it does exist.
I think you have elements of things that are right there. I certainly think it is the mean value theorem. I like that you said that the conditions of the mean value theorem were met, that v of p is a continuous function because it's differentiable. That's really important that you're stating that you can use the mean value theorem. But remember that the mean value theorem says, oops, says that there's going to be some value c for which the instantaneous rate of change, which is what I've written down, is equal to the average rate of change. Okay, so you need to say that that's what's true, and then you need to calculate that. Okay, and that, if you calculate it, is actually going to be equal to 0 over this interval, because you're going to take 55 minus 55, and that's going to give you 0. And so that says that there must be some value c for which that instantaneous rate of change is equal to the average rate of change.
You also say that since it's changing direction, that the velocity has to have a minimum at some point, and therefore the acceleration will equal 0 because the derivative of the graph will equal 0.
Probably. But I would talk about make sure you talk about horizontal tangents as well. Okay, and make that connection between the slope of the horizontal tangent and the derivative. Okay. Part B is to use the trapezoidal rule, and we spent a lot of time yesterday talking about the trapezoid rule. The answer that I got is 40.75 meters.
Quick question. Do we apply, so I know there's the one over like the A minus B part that we put in front. Like that we put in front of like the integral that we multiply out after.
You're not doing an integral here. And that's not what this is asking you.
Okay, okay, I just want to double check, just make sure not to apply that.
Because that's not what it's asking you for. When we did that yesterday, it was because it was asking you to find the average value. So you use the trapezoidal rule to find the whole area under the curve and then divided it by the interval, but that's not what you're being asked to do here.
Okay.
Okay. All right, we good with part B? Okay, so I think this is the part that is similar for both exams. Okay. So part C says, if the integral from -6 to 5 of f of x dx is equal to 7, find the value of the integral from -6 to -2 of f of x dx. Okay, and I get that my answer is 9 pi over 4 minus 4.
Can we go over that?
A little bit. Okay, so there we go. So what you have to understand or remember is that, so we know this, that f of x, we know that that's going to be equal to 7. Okay, and that's the whole interval. But remember that the whole point of f of x being a continuous function and all that, which it is that then I can break this up. So I can say that this is going to be this plus the integral from -2 to 5 of f of x dx. I can break my integral. That was one of the theorems and one of the properties of integrals that we had, was that I can break it at any value in the middle of the interval. Now note that they don't plot the entire interval on that graph. Okay, they only plot it from -2 to 5. This is what you're looking for. So -6 to -2, f of x dx. I'm just going to bring this over to the other side, and that's going to give me 7 minus this. And then this is just the area under the curve. And you find the area under the curve. You've got triangles. You have kind of what's left over with half a circle. So if you go back and look, you can find this and that. Those are actually going to cancel each other out. You can figure out where that intersection point is, and you find this and all of that. Those are all triangles. The only tricky part is over here, and what I did, and this is a trick we talked about, is you can find the area of that rectangle. It is 9. Right? Equals to 9. And then this part here is the area of a quarter of a circle. So that's going to be 4 pi r squared. So that's 1/4 pi 3 squared. So this area down here is 9 minus 9/4 pi. And you just add that to the rest of your areas. Okay. All right. So part D, evaluate that integral. I get 2 plus 2 radical 5.
If we have a radical, should we just leave it in the radical? Okay.
Yes, they said, because number one, they said, don't try to simplify your answers and do algebra because they don't want you to mess it up. And number two, you don't need a calculator. So it's okay to leave it like that. I would say do obvious algebra, and especially if it helps you understand something, to do that. Okay, we good with part D?
I got 8 minus radical 5.
I don't know why.
No.
So let's just set it up real quick. Okay, so you're taking your integral from 3 to 5, 2 of f prime of x plus 4 dx. I can make that two integrals, so I've got 2 integral 3 to 5 f prime of x dx plus the integral of 4 from 3 to 5 dx. The antiderivative of f prime of x is f of x. The antiderivative of 4 is 4x. I'm sorry, that's a plus. Whoops! Totally did not want that to happen. Okay, and then you're just going to go from there. So this is going to be 2 times f of 5 minus f of 3 plus 4 times 5 minus 4 times 3. So I might have messed it up, but I don't think so.
Do we have to split it up?
No, I just felt that if you split it up, it's easier to see that you're taking the antiderivative of that. So you don't have to split it up. It's addition and subtract, it's addition, it'll commute. So
I think because I pulled the 2 out of the 4 as well.
well, then yeah, but that's not there.
Okay.
So because the 2 is only multiplied by the f prime of x, if you go back and look. Okay, they're right there. Okay.
Okay.
All right. I myself messed up part E. I only found that x was equal to -1. I did not find what the value of g was. So g of -1 is going to be the integral from -2 to -1 of f of t dt, right? So that should give me the area under the curve from -2 to -1, which is this, which should be a half, right?
So wouldn't it be the largest if you went from -2 to 5?
No. Well, first of all, how are you justifying that?
Because aren't you finding the area under the curve of f of t? If you're finding the integral of f of t, you would need to find the area under the curve. And if you did it from -2 to 5, it would actually be the largest.
I'll believe you, Sarah. I'll believe you 100%. Yeah, that was what my problem was that I forgot I had to find g of x. Good call. What'd you get for an answer, Sarah?
I actually did the same thing as you. I didn't find g of x. I only knew that it was from -2 to 5. That
Okay.
would be the largest.
All right. So we don't actually have our answer for g of 5. You'll have to, unless somebody else did it right. Helen, I'm looking at you even though I'm not. Helen, what did you get?
I don't know what's G of X.
Okay.
You didn't give us a, like,
Yes, but you do, because this is going to be the integral from -2 to 5 of f of t dt. So you're just going to find the area under the curve. And actually, did we find that earlier?
Yeah, so would that be 11 minus 9 pi over 4?
Yeah, I think it is. It's the area under the curve that we found up here. So that's what I'm going to go with, and that would make sense because they're not trying to give you too much work to do. Good team effort. When
I the maximum though,
because you're adding up all the area under the curve, so those cancel, and then it's going to be all of the rest of that red area minus this tiny little bit here. So that's going to give you the max because all of that area is above the x-axis. So if you take that limit, I get 4 over 1 minus pi over 4. I just substituted in.
is it okay if we leave it like 18, the 18.6, which is what it simplifies out to? Not simplifies, but like when you put it in your calculator, that's what it comes out of.
I guess. I don't know. I don't have the guiding. I don't have the grading guidelines. All I know is they specifically say that you don't have to like over manipulate the algebra or oversimplify. So if you're going to take what you got there and turn it into a decimal, as long as you did it correctly, you're good. But every additional manipulation that you do, that leaves you open to making a mistake. So I just offer that as a caution to everybody. And then my answer for the last part is that it is increasing.
Can you just tell us what your justification would be for it?
Sure. So what I really want to know, so it says, is the rate of change of G increasing or decreasing? So that means what I really want to know is G prime of X increasing or decreasing? So that means that I really want to know what G prime, what G double prime of X is, right? And if G double prime of X is greater than 0, then it's increasing. If it's less than 0, then it's going to be decreasing. So if G of X is this, then G prime of X means I apply the fundamental theorem of calculus. So that gives me f of x. And then if I take the derivative again, I get f prime of x. So I want to know if f prime of 1 is greater than 0 or less than 0. Because t of 1 has somehow magically become x of 1, I think. That's how I would say it. Or maybe that's not right.
I think you're right, because g of x equals the integral from -2 to x of f of t.
Okay.
So maybe that's why they said t equals 1.
I think so. and I think it would actually get like way too complicated otherwise, to be quite honest. So then you just want to look at your graph, and I've got a lot of stuff on my graph now. But if we look at t equals 1 right here, what's f prime going to be there?
Positive?
Yeah, it's positive. It's actually equal to 2. But that's going to be positive. So it's increasing. That's my way of looking at it.
Do we have to find f prime of x is 2, or
No.
we can say it's
I
positive?
think you can just say it has a positive slope.
Okay, thanks.
I think I had found it back in part C when I was finding the area under the curve. So I just knew for a fact what it was because I'd already found it, but I don't think you need to do that. Okay. So pep talk, and then BC folks, if you want to stay for 30 seconds, I can show you my answers. The exam is Tuesday. Make sure that you have your e-ticket. Make sure you have the number. Make sure you have a plan for how you are going to upload. Okay? If you are going, no matter what you're going to do, you need to have something ready before the exam begins. Either have your pieces of paper and with your initials and your AP ID at the top and have those pages numbered. Have the Word doc open that you're going to use, or the Google Doc or OneNote or whatever, but make sure you are all set before that day. Make sure you have your plan. Make sure you have a backup plan. Make sure you have sharpened pencils. Make sure you printed out everything you're supposed to print out, okay, so that you are ready. Get a good night's sleep. That is probably the most important thing, okay, is that you have a good night's sleep. You can do this. Remember that you don't have to answer every part of every problem to get a 5. I would recommend you skip around. Take a minute. It's worth a minute to read through the problem and make sure that you're doing the parts that you know how to do. Okay? If you get stuck on something, go on. All right? Try it. Give it a good shot, but move on. The last thing that I ask, hang on, Lauren. The last thing that I ask is that you give this your best effort. You have worked long and hard all year. Show respect for yourself, show respect for SEM, and show respect for me by giving it your best effort. So don't just show up and really try your best. Okay? You deserve that, and SEM deserves that effort from you. Okay? So you can do this. All right? Lauren, what was your question?
For the practice question we did today, it was kind of 2 parts, but still 1 question. Would this be considered like question 1 on the exam with 2 different tables? Okay.
I mean, it's a sample question, which would make me think that real questions would look like that.
Okay,
you
even
know
though they don't correspond with each other?
Yes, and they said in the write-up that the questions will have many, well, they said the questions will pull together ideas and concepts from many different areas of calculus. That's what they've said from the beginning. So that could really happen.
Okay.
But I don't know.
Yeah. Okay, thank you.
Okay. All right. People who are taking the AB exam, if you would like to go, well, you should go. Have a good weekend, rest up, study, okay? And then BC folks, I'll show you my answers for the BC if you want to stick around for 2 minutes, okay? Bye, guys. Okay. Share. I'm just going to do it on on my smartboard. So for part E for you guys, you had to do the third order Taylor polynomial. I got 3 minus 2x plus 3 halves x squared minus 23 over 6 x cubed. Does that sound right? Agree with what you have? Okay. Part F was to find h of 1, and I got 2 minus 11 over 24. Again, they talk about not going crazy with simplifying things. So as far as I would think, that would be okay. And then we can talk about any of these that you want if you have time. My answer for part G was 1 over P. And as we all know, I could be wrong. So if you're making a funny face because you don't agree with me, let's do it together because, like I said.
I got something different for E and F. For E, I got 23, or for the last term, I got negative 23x to the third over 2 times 3 factorial.
Well, the third term is f triple prime of 0 is x cubed O over 3 factorial. Maybe I messed that part up. Right?
Well, the third derivative of f at 0 is negative 23 over 2. So would you keep that in the denominator?
I would keep the 2 in the denominator, yeah. Yes, right. 100%. And actually, this is wrong. Helen, why are you not telling me that's wrong?
I didn't do the BC one.
Helen! 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 Well, it should really actually be 12, which might very well mess up that answer.
Yeah, I got something else for that one too.
But is this what you got for E?
Yes. I kept it as 2 times 3 factorial, but that would be the same.
Yeah, okay, then that was my bad there. I'm just trying to make, because I forgot it was factorial. I just had 3, okay? So then this part of my answer here would be wrong. Lauren, what did you get?
I got 97 over 48, but that could also be wrong. I just plugged in 1.
No!
Oh, wait.
You didn't just plug in 1?
No, I didn't just plug in 1. Sorry, I looked at it wrong. I took the integral of each of the terms and then plugged in 1.
Exactly. That's what you should do. So you should take the integral from 0 to 1 and take all of these terms and then take the antiderivative term by term.
Okay, yeah, that's what I did.
Yeah, and that'll give you of 1.
And then could you go over how you got part G?
Yeah.
Yes, thank you.
So let me see what the problem was and what the question is, because I don't have, this is where I want to be. Content library. I think it's under review materials. There we go. Okay, so the last part was, it's just evaluate that where P is greater than 0. Dang it, there we go. Okay, so part G. So I've got my integral 1 to infinity 1 over x to the p plus 1 dx. So by the book, it tells you that you can't really take an integral to infinity, right? So it really has to be the limit as a goes to infinity of the integral from 1 to a of 1 over x to the p plus 1 dx. Right?
Yes.
Okay. says the girl who didn't do the problem.
But I know it's improper integral.
Yes, okay. And then what I think is really important is they tell you that p is greater than 0, which means I can write this as the integral from 1 to a of x to the negative p plus 1 dx. And then I just evaluate the integral. I still have to keep my limit out here. So that's going to give me x to the negative p plus 1 with the parentheses around it, plus 1 over negative p plus 1 plus 1 from 1 to a. So again, limit a goes to infinity. This is going to give me x to the negative p over negative p from 1 to a. And then I've come to a limit, so I substitute in. So I can keep out the negative 1 over p, and then I've got a to the negative p minus 1 to the negative p.
Oh, okay.
Right?
Yeah.
I'm sorry, there should still be a limit sign here. And then if I substitute the limit in, I've got negative 1 over, well, I'm going to write this one more time. Hang on. So if I make this the limit as a goes to infinity, I've got negative 1 over p. That's going to give me 1 over a to the p minus 1 over 1 to the p, right? So now if I substitute in negative 1 over p, 1 over infinity to the p minus 1, this is going to go to 0, right? Because it's 1 over infinity.
Oh.
And so that's going to give me positive 1 over p.
Thank you so much.
I could be wrong, but that's the way I look at it.
Yeah, no, I did it wrong. But thank you so much.
Okay? Good luck, guys.
Thank you.
Bye.
Bye.